Professor Ashish Kumar.
Yeah.
Okay, nice to meet you all.
Yeah.
Yeah.
Do we have the technical team online? Do you know, is that what ISCA Webinar 4 is? Because I have no familiarity with how people share their screens. So I'm hoping that there's somebody who can advise on how people share their screens. Oh, there's the webinar.
Okay.
Yeah.
Good morning. Good afternoon, I think.
Good afternoon for me. Good morning to you.
So we have another 20 minutes.
Yes. Yes, I thought I would log on early because last time
definitely.
But it seems to be all working very smoothly today.
Yeah, I think there will not be any problem.
No, that's good. Professor Ashish is our first speaker, yes?
Yeah, Ashish.
Yeah. Professor Ashish will talk as a first invited speaker.
Okay.
Yeah.
Excellent.
You have the list with you?
I do. So we only have the 4 speakers, is that correct?
Yeah, 4 speakers. So kindly introduce the speaker.
Yes.
They have their biodata before their abstract. So
yes.
So as a chairman, you please introduce them.
Yes, I will do that. So we have a bit of spare time in the session, so I don't have to hassle people about the timing.
It is 20 minutes time, and it would be better they can finish 18 minutes and for 2 minutes there would be discussion.
Questions.
Or if they exhaust the entire time, then it is difficult to spare any time.
Okay. Okay. And does it work so that only the speakers have access to the speaker? I mean, so that those just listening in on the webinar.
When his screen would be shared, only speakers should speak.
Okay. And
it would be better others should be in unmute in mute condition. So after the end of this presentation, then others should speak.
Okay. So for question time, will people put their questions in the chat box, or if they raise a hand, how do I allow them in?
Yeah, if they are in the panelist, they can directly speak. Those who are in the attendee list, they can put their question in the chat box.
Okay. Okay. And Professor Ashish, you're comfortable with sharing your screen?
Yeah. Sharing.
Yeah, you can check if there is a. Yeah, it's visible. Sir.
Okay, beautiful. It's all working.
Yeah.
Excellent.
Yes. Is it visible? No, it's okay.
Yeah,
yes, it is. A lovely photo of coastal ecosystems.
Yeah.
Do I say the name of your university as Vidyasagar?
Vidyasagar University.
Okay. Thank you.
It is in West Bengal, Midnapur.
Yes.
Yeah.
Okay. All right. So we've got 15 minutes, I guess, until we get started.
Yeah. Let even our co-chairman still not joined. So Dr. Ilengo from Chennai.
Yes. And he's our second speaker, I think, yes?
He's
No, he's our third speaker. I got those the wrong way around. I'd better check my order.
উপরে ইকুয়ালি চেঞ্জ করে করে যাবে না?
We have our first and our fourth speakers.
Yeah.
We're still waiting for our second and our third. Thank you very much for being so early. It's always reassuring.
Earlier, Robin, I saw you attended some other program also in this webinar program, in that carbon sequestration program. So you could able to, there was no problem in the present, you could able to see everything nicely? Or
it's all worked very smoothly. I've been most impressed. There was a very interesting seminar on fisheries, plenary yesterday on fisheries, and then I sat in on the beginning of theme 3, session 1.
Carbon sequestration, I saw that you were attending that as attendee.
No, it all went very well. So, Professor, do you work in the Sundarbans area in West Bengal?
Yeah.
Okay.
Yeah.
We have a project.
Yeah, I have many projects, but this is done by us in the West Bengal coastal areas for 30 years or 40 years, field visits, and also the interactions with the local people, and with the help of the remote sensing imageries, temporal remote sensing imageries.
Okay.
I have done this.
I have visited very briefly. It was
yeah. Very briefly, I try to speak in very briefly. I have many slides also. 59 slides are there, but I shall try to just constrict within 18 minutes time.
Okay.
Yeah.
I will.
I would like to inform Dr. Paul that Robin used to visit that Sundarban area in both India and Bangladesh very frequently. Every
I see.
year, at least twice or thrice, he used to visit that area.
Okay. Fine.
I've spent more time in the on the Bangladesh side than
Bangladesh sides of the Sundarban. Yeah.
But I have visited West Bengal. But I don't know it well, but I have visited, which has been wonderful.
Okay.
And Dr. Singh, you're in New Zealand.
Yes. Yes, I am
Okay.
Robin. Yeah.
Okay, so it's afternoon for you as well.
Yes. Yeah. About 5 p.m. Yeah, 4:50.
Okay, so not too late.
Yeah. Not too late now. No, it's
But the afternoon sessions must be very late for you.
yeah, late afternoon. It gets late. Yeah. Yeah. So you are based in Canberra, you said.
In Canberra, yes.
Yeah. Yeah. So I did work in Australia for some time. Yeah.
Who was that with?
So that was almost 10 years back. I was with the CRC for irrigation features.
Okay.
Yeah, located in Western Sydney at
Western
that time.
Sydney.
Yeah.
Oh, okay.
Yeah.
We have a project with Western Sydney with Dr. Basin Maheshwari.
Yes. So yeah, I used to work with. Yeah.
Okay. So that's on groundwater mainly. Were you involved with that at all? Or?
No. I did work mainly on the CRC irrigation features project into Western Sydney with Basant.
Okay.
And then in 2010, I moved on across the water here to New Zealand, Massey.
Yeah.
Yeah. And now we stay in touch quite nicely, but I'm not involved with that project. But I'm aware about that one a little bit. It's in Rajasthan, isn't it?
It started in Rajasthan, yes, but it's being picked up. The idea of the community monitoring for groundwater is being picked up nationally as part of the policy, which is excellent.
Yeah.
We're very excited about it. Basant has put a lot of time and effort into making people aware of the work and getting it published and getting media coverage. He's done a very good job.
Yeah. I know, that's good. So you got another project or more projects in India, or?
We have, most of the projects in India are joint with our regional projects, so involve India and Bangladesh and Nepal. So we do have quite a few projects in the Eastern Gangetic Plain. So mainly West Bengal, a little bit in Bihar. We don't have so much going on in other parts of India at the moment, at least in ACR. Yes.
Yeah, because I remember Professor Hector Milano used to have a project in, what was the catchment? Musi catchment in Odisha or Andhra Pradesh.
Okay. Yeah, there was some work in Andhra Pradesh and some work in Odisha.
In Andhra Pradesh, sir.
But that's some time ago.
Yeah, in Andhra Pradesh. Musi River is in Hyderabad. It flows through Hyderabad also. Now it is in Telangana, I should say.
Yeah.
But sadly, there has been no field work from Australia to the Ganges this year.
No, I can imagine that. Yeah, all the COVID restrictions.
It's okay for us in New Zealand and Australia, but I guess it's been much tougher in India.
Yeah, I would like to hear what's the situation. So how is Ashish in Bengal with the COVID restriction?
No, still not, but I think should be there after a few days.
Okay. Are the case is going up again, or?
Because in our state now election is going on, so that's why. But after the election, I think some cases are already growing.
Okay.
Yeah. So some restrictions will be started again.
Yeah, it's difficult to see what's the end of the tunnel, eh?
Yeah.
It's like, okay.
So, Dr. Paul, you please now stop sharing. Already Dr. Ilengo has joined.
Yes.
So we can, within a minute, Robin, with your permission, can we start the program?
Yes, certainly. Welcome to Dr. Ilango. Good to see you here.
It's okay.
Good to see you.
Hello, good morning.
Just 1 minute, I have to introduce regarding the sessions, then Dr. Robin can continue.
Yeah.
So
Okay.
I welcome you all in this important session. This session is on river flow dynamics, bank erosion, surface and underground water flow modeling vis-a-vis climate change. So this session will be chaired by Dr. Robin Johnstone from Australia, co-chaired by Professor L. Ilango from Chennai, and Dr. Suji Desai from Goa will act as a rapporteur of this session. Before that, I would like to introduce our chairman and co-chairman, Dr. Robin Johnstone is the research program manager for water ACIR Australia, that is Australian Centre for International Agricultural Research, and she's working and associated with ACIR since 2007. Before that, she was a principal researcher with the International Water Management Institute, that is IWMI, and worked in Myanmar. She has previously worked with the Murray-Darling Basin Commission as well as Mekong River Commission as environment advisory. And also she has worked with the Bureau of Rural Science and Geoscience Australia. Dr. Johnstone holds a BSc Honours degree from Australian National University, MSc in Geochemistry from University of Leeds, and a PhD from the University of New England. She has more than 1,500 citations as well as H-index 20, present H-index. So I would also like to introduce our co-chairman, Professor L. Ilango. Is an hydrologist and professor in the Department of Geology, Anna University, Chennai. Dr. Ilango is currently working as a hydrologist at Anna University, Chennai. He had carried out his postdoctoral work at the University of Birmingham under Indian National Science Academy and the Royal Society London Fellowship Program. He has overseas experience in France, Finland, Germany, Hong Kong, Hungary, Italy, Japan, Netherlands, Russia, Spain, Switzerland, Singapore, Sweden, South Korea, South Africa, Thailand, Tunisia, UK, and USA. I think most of the continents he has overseas experience. He has published over 175 research papers, and 25 scholars have completed their PhD under his guidance until 2020. So I invite Dr. Robin Johnstone to chair this session. I also invite Dr. Ilango to co-chair this session. And I also invite Dr. Sujit Desai to act as the rapporteur of this session. So now Robin, you can start the proceedings of this session. Now I think it is 9:29, so within a minute you can start the proceedings.
Just a minute.
Thank you very much for that kind invitation, and welcome to this session, which is session 2 under theme 3. So session 1 started yesterday. We have 4 speakers in the session, and there's an allocated time for each talk of 20 minutes. So nominally 18 minutes for the talk and 2 minutes for questions. So I'd ask you to keep to time as much as you can. Can I please ask those who are not speaking to mute your microphone while the speaker is speaking? So I'd like to welcome our first speaker for the session, Dr. Ashish Kumar, who's from the Department of Geography at Vidyasagar University in West Bengal. He completed his PhD degree in geography from the University of Calcutta on coastal geomorphology and ecology in parts of West Bengal in 1992. And he also carried out 2 research projects on the topic morpho-ecological dynamics of the Sundarban coastal tract and on coastal tourism prospects in West Bengal and Odisha, funded by UGC during 1993 to 96 in the Department of Geography in Calcutta. He's authored reference books on coastal geomorphology and environment and on tsunami, the disaster in the Indian Ocean nations. He's also done various consultation works on environmental auditing during 2006 to 8 at Vidyasagar University under a group of environmental scientists. He's worked on research projects relating to hydrogeomorphology and on water quality of river basin wetlands funded by PHE from 2012 to 15. He's supervised 30 PhD research scholars in the Department of Geography and Department of Remote Sensing and GIS at Vidyasagar University on aspects of coastal geomorphology, coastal agriculture, land degradation, forest degradation, coastal hazards and disasters, livelihood security of coastal people, geospatial techniques in coastal studies, coastal tourism environment, coastal morphodynamics and integrated river basin management. He's published about 150 research papers in national and international journals and as book chapters. He's engaged in teaching physical geography, oceanography and coastal management in the Department of Geography at Vidyasagar University since 2006. And currently he's doing research on coastal habitats, coastal geomorphology and coastal hazards in Indian coastal zone and island systems. He's associated with the Committee of Quality Assessment of CRZ maps in West Bengal under the Department of Environment, and he's received the International Award from JRC in the USA in 2017, and also elected as the President of the Indian Institute of Geomorphologists for the year 2020. Today, he'll present to us on the topic of dynamic behaviours of the estuaries in response to the phenomenon of global warming in coastal ecosystems of West Bengal and Odisha. Thanks very much, Professor Ashish. And
thank you, Ravin, and other chairperson and co-chairpersons. So my paper is on the dynamic behaviors of the estuaries in response to the phenomenon of global warming in the coastal ecosystems of West Bengal and Odisha. Estuary is the arm of the sea, and where the salt water is sufficiently diluted with the mixing of the fresh water. In our coastal parts of West Bengal and Odisha, there are many estuaries. In the background of my first slide, you can see that how the mangroves at the seafront of Sagar Island in Hugli estuary is frequently getting affected at the time of the landfall of the cyclones. The coastal plain estuaries are sediment sink, and they try to adjust with their changing environment of hydrodynamics and sediment input systems, but never achieve the equilibrium. A disturbance regime is generated at present in the tropical coastal systems due to the impacts of the global warming phenomenon, and for which the estuaries are affected by bankline shifting, shoreline retreats, sediment encroachments, thalweg shifting, and widening of the estuary fringe tidal flats. And finally, the mangrove ecosystems and dune ecosystems of the coastal fringes are largely affected by such dynamic behaviors of estuary channels, episodic energy inputs, shifting sands, ephemeral rise of seawaters, and tidal drainage loss into the higher tidal flats of the coastal areas. The objectives of my study is to find out the dynamic behaviors of estuaries, then to explore the impacts of the phenomenon of the global warming on the coastal environments, to identify the impacts of the global warming on the coastal ecosystems in the study areas. This is the methodological flowchart. I have used the remote sensing images on the temporal basis and then extensive field surveys and other attribute data to find out the changing estuarine dynamics in the coastal parts of West Bengal and Odisha. Here you can see that on the top, there are the locations of the different types of the estuaries, the delta plain estuaries of Mahanadi and Brahmani Boitarani in Odisha, and then Chilika Lagoon. And in the lower part, you can see that there are different types of the estuaries located in the West Bengal coast, particularly starting from the Hugli estuary on the western margin to the Rangafala in Ichamoti estuary on the eastern margin. And West Bengal coast and Odisha coast are classified on the basis of the geomorphology and morphodynamics. Actually, Odisha has the 7 coastal districts and West Bengal has the 3 coastal districts, and most of the estuaries are located there. And I have classified them into open marine sandy shores, lagoon fringe shore, delta plain and delta front coast, bay fringe coast, deltaic beach ridge coast, coastal fringe of estuarine delta, and coastal fringe of tidal delta. This is the estuary in which actually from the landward sides, the river inflow and the river input of the sediments which take place in the coastal zone through the estuary sections. And from the marine sides, we are getting the influences of the tides, waves, and the marine sediments inputs. So perhaps the most common origin is the drowning of the river mouth valleys, which are basically found in the Sundarban areas. And the bar-built estuaries evolved by spit extension across the embayment, which are basically found in the most of the estuary mouths of Odisha. And these are the plan shapes and the profile views of all types of the estuaries. All types of the estuaries have resulted from the rise of the sea level during the Holocene epoch. And here you can see that the upper the figure of the top, the similar characters of the estuary, it is available in the West Bengal portions. And this is the bar-built types of the estuary plan view that is available in Odisha coastal areas. So estuaries are again classified on the basis of the circulation, that is the saltways estuaries having the sharp halocline, the partially mixed estuary having weakly developed halocline, and the well mixed estuary. But for the case of West Bengal, we have seen both the saltways estuary and partially mixed estuary in the 2 different seasons in the behavior of the Hugli and Ichamoti Raibangal estuary. But no halocline zone actually take place during the dry season in many estuaries of Odisha and West Bengal also. And these are the diagram by which you can see that the salinity profiles of the estuaries by the mixing of the fresh water and the seawater. And this is the Hugli river mouths, which is filled up with the sediments and locations of the many islands, bars, and tidal flats. And these 2 islands, you can see the distal islands, which are located 11 kilometers south of Sagar Island, the Jombu Island, the Juksar Island. And I have used the temporal images, and by overlaying this data, I have shown that how the Jombu Island has been reduced into smaller size and shifted their positions, and Juksar Island also shifted their positions. And I have also identified the locations of the sandbar in hectare in different cyclone years in the Hugli estuary. So there is a positive relationships with the cyclone landfalls and the movement of the sands into the estuary. And this is the mathematic chart of Hugli estuary section. And if you just draw the cross sections, you can see that this is the single channeled estuary here in the upper sections. But again, it is separated into 2 different channels where the islands are located in the, this is Noyachora Island sections. You can see that it is in the Holdia channel and the Rangapala channel separated by Noyachora Island. And then towards the south, the mouth of the estuary, you can see that how the sediments are dumped from the marine sites. And in the extreme south, we can see that the depth of the high water is also very minimized, only 2 meters depth, but most of the area is occupied by the sands from the marine sites. And again, I have classified the entire Hugli estuarine morphology into 3 groups. The subaerial parts include the channel margins and banks, islands, and dunes. And the intertidal parts include the tidal flats, sea beaches, sandbars, and the subaqueous parts include the channel bottom features. So here is the location of our Holdia port, the navigable port, most important port in West Bengal, on the Hugli bank, on the western bank of the Hugli estuary, where the huge rate of the siltation is a typical problems. Here you can see that the minimum required gap is 7.7 meters to enter the larger ships into the port. The present gap is the 8.6 meters from the riverbed to the high water level, and feared gap is 7.1 meters. So that's why, because of the high siltation rates, the continuous dredging operation is going on to run the port. And this is the salinity front and turbidity maximum zone in the estuary. In the dry season, the turbidity maximum zones actually pushed into the seawards. In the fresh rainy season, pushes into the seaward sides, and in the dry season, it pushes towards the landward parts. And here you can see that the month-wise discharge of the river systems in this part of the Sundarban coast. In the month of September, in the month of July, you can see that the highest contributions of the discharge, the freshwater discharge takes place. But still, the average discharge in the river system of Hugli downstream section was about 10% of the average discharge of the Indo-Gangetic Delta. So only 10% discharge actually coming into the river mouths. So that amount of the freshwater is not sufficient to support the largest mangrove ecosystems in India. So at that time, the high tide also achieved 6.24 meters in the month of July, when the maximum freshwater discharge takes place, and 6.49 meters also take place in these sections where Haldia port is located. And the tidal features, the semi-diurnal tide, and the maximum range actually 4.27 meters to 4.57 meters. Tidal influence felt up to distance up to 300 kilometers from the mouth to Navadvip. And then tide exhibits a positive asymmetry. And in the tidal cycle, flood tide is the short duration, 3 to 4 hours, and the ebb flows remaining 8 to 9 hours. So flood velocity is much higher than the ebb. And this is the flow pattern of the ebb current and the flood current in the Hugli estuary. And I have measured the concentrations of the suspended loads in these sections of Diamond Harbour, where it is 1.91 to 2.53 milligram per liter. And I have also collected some data from the flood years, significant flood years since 1950 to 2008, and the cyclone years, 1942 to 2009. So maximum episodic events are actually taking place in this area for the disturbance of the entire systems in the Hugli River. And I have also actually overlaid the data of 1978 bathymetric profiles with the 2011 CPT survey profiles, where it is showing that very significantly that Noyachar Island is gradually shifting towards the western part, where Haldia port is located here, but the Rangapala channel is getting deeper and deeper by the downcutting actions. And I have estimated the siltation rates also in a certain sections, which is showing that 11 million ton per year actually siltation is taking place in this part. And that's why the Balari Bar, Noyachar Islands and such islands and bars are growing. So the continuous dredging operation is going on to maintain their port, the navigations. This is Noyachar Island dynamics, the configurations of the shorelines. And this is the stratigraphic column. And from the stratigraphic column also, I have collected the 3 storm depositional layers from Noyachar Islands, which is showing that the influence of the storms in the formations and evolutions of the islands into the estuaries. This is the erosive sections of Noyachar Island on the eastern bank. And here is the survey pit we have constructed in the central part of Noyachar Island to find out the sedimentary compositions in this area. And this is the unsupervised classification showing the land use patterns and how the salt marshes are actually growing faster than the mangroves. Mangroves are getting reduced because of the salinity, high salinity into the estuaries, and also the concentrations of the sediments coming from the marine sites into the estuary sections. And with my students, when I visited this area, that extensive salt marsh tracts have been grown towards the western parts. And however, in the southern section of Sagar Island is getting eroded since 1987, and how the mangroves tree trunks have been exposed on the seasides. And I have measured the tidal presence in Muriganga parts of the estuary. Since if you just compare with 1987-2018, it has been increased to 2,36,049 cubic meters of the discharge. And the erosion rate, you can see that 28.6 meter per year in a village, 16.8 meter, 14.4 meter on the bank of Sagar Island. And how the southern part of Sagar Island is getting affected by erosion, and the tidal inlets, which are located in these parts of the estuary sections, are getting filled up with the sediments in the ephemeral lives of the seawater. I have picked up 13 major cyclones in the 2 decades. And you can see that concentrations of the high magnitude cyclones within the previous decades. And most of them landfall actually took place in the Sundarban coastal area and in the northern part of the Odisha. So they actually influencing tremendously on the estuary sections to make the dynamic behaviors of the region. And if you see the sea surface temperatures in 2019 and 20, in the northern Bay of Bengal, you can see that average sea surface temperature is 30 degrees centigrade. So this is a tremendous effect over the formations of the cyclones in the northern Bay of Bengal. And the SSH, the sea surface elevations, satellite altimetry data, showing that I have plotted it since 1990 to 2020 at the 7 centimeter per year, it is increasing. So this type of the phenomenon actually creating the major problems in the estuary and behaviors. This is the Ayla storm surge photograph, and this is Amphan cyclone which took place in 2020, and for which we have seen that the tidal limit extended to 300 kilometers from the mouth of the Hugli estuary, and the soil salinity is also increased towards the landward sides. And here you can say after 2009, how the red color tone is showing the high saline zones, they have been shifted to the landward parts where the reclaimed Sundarban is located from the forest margin area. And here the aquifers, the saltwater aquifers, also lying very close to the surface. And this is the topsoil removal from the Sundarban area where mangroves are located. And I have compared with the 2000-2010 data to find out the erosion rates even in the remote areas where settlements and the reclamations process are absent. And this is the feature you can see that the Halliday Island, which is located in the Matla estuary, that is the tidal part of the delta of Sundarban, where the mangroves are getting affected by the overwash sands. And then the lower parts of the mud banks are getting affected by overwashing, surface etching, gullying, and fingering. So ultimately, this island has been getting eroded. And in the lower parts, that means at the coastal fringe area of the Hugli and Submarine estuary in Odisha, how the overwash process actually damaging the mangroves and the salt marshes. And this is the overwash sand layers I have identified from the Sundarban areas. And the mangroves are also adjusting with the sea level rise. The germinated seeds are actually transported towards the 145 kilometers inland distance of the Hugli estuary. And this is the erosion rates you can see in Odisha coast, that 3 districts are getting affected by erosions and the other districts of the northern parts are getting affected by the accretions. So this is the Subarnarekha estuary and dynamics of the shoreline configurations. Just if you compare with 1973 and 2013, and this is the locations of the mangrove forest, how they are getting affected by the, and this is the data I have generated with the eco sounder process and other activities, the tidal prisms in the different channels of the deltaic area. And then this is 1999, the flood impact, the coastal flood impacts over Mahanadi Delta, you can see that. And then the Boitarani and Brahmani Delta, a cyclone passage you can see across the sand dunes, the speed barriers, and the mangroves. And then this is the overwash activities over the mangrove forests. And this is the Chilika Lagoon, which is connected with the Dwaya and Devi river systems in Odisha. And this is the speeds, and this is the tidal inlets. And the Chilika Lake, actually, the water spread area constricts in the dry seasons as 797 square kilometer, but enlarged to 1300 square kilometer in the rainy seasons. And the tidal prisms I have measured since 1972 to 2013 in Chilika tidal inlets, and it has been increased tremendously, 202 million cubic meters of, and if it's plotted in the bar graphs, you can see that from 1972, it has been increased to 2013 after cutting the mouth of the spit in Chilika Lake. And this is the field activities. And today, these large dune systems, which were located in the Chilika spit, have been eroded. And tidal inlet through the world exhibits several consistent relationships that have allowed coastal engineers and marine geologists to formulate predictive models through analysis of inlets, whereby inlets parameters are plotted against one another. 2 important correlations have been discovered. The inlet throat cross-sectional area is closely related to tidal prism, and ebb-tidal delta volume is a function of the tidal prism. And the strong longshore currents also disturbing the morphology and the sedimentary systems of the tidal inlets and the estuaries, because most of the actually the longshore currents are coming from the southwestern sides of Odisha to northeastern parts of West Bengal coast. Here you can see that overall relationships, how the tidal prisms actually demonstrate the strong correlations between the inlet's spring tidal prism and its throat cross-sectional area. And this is the Walton model, Adams model, how the ebb delta has been spreaded, and they have the relationships with tidal prism. And in the Chilika Lagoon, we have seen that how the inlet throat and the F delta lobes have been expanded towards the sea. So this is the major findings. The marine sediments pushed into the estuaries by storm surges. Islands and bar-built estuaries are changing in shape. High SST in summer months and steady rise of SSH per year causing the erosion, shoreline changes, and frequent saltwater inundations into the coastal lowland. Overwash sand fan lobes are rapidly encroaching into the backshores. Tidal presence increased into the estuaries. High magnitude storms frequencies increased in the previous decades. Landfall concentration of cyclones is found to the alluvium source of West Bengal and Odisha coast. Bars and barrier breaching events increased during the storms. Coastal squeeze on the sea face and the widening of the estuaries in the inner sections of the coastal plain rivers. Soil salinity and tidal limit of the river mouths advanced inland along the estuaries. Strong longshore current during the summer months transport sediment load from the southwest to the northeast directions. Seasonal constriction and enlargement of the water spread areas occurring in Chilika Lagoon. All the estuaries and lagoon are acting as significant sediment sinks into the coastal environment by advancing sea. Coastal dune ecosystems and mangrove ecosystems are largely affected by the impacts of the phenomenon of the global warming today in the West Bengal and Odisha coasts fringed by northern Bay of Bengal. Thank you, everybody.
Thank you very much, Professor Ashish, for a very comprehensive discussion of what's obviously a very dynamic environment. We're a couple of minutes behind, so I might ask people to hold any questions until the end of all four talks, and we can take some questions then. But we'll move now directly to our second speaker, who is Dr. Y.R. Satyaji Rao from the Deltaic Region Centre of the National Institute of Hydrology in Kakinada in Andhra Pradesh. So Dr. Satyaji Rao joined as a scientist at the National Institute of Hydrology in Roorkee in 1992 and has 28 years of research experience in hydrology, especially on catchment water balance models, hydrological monitoring of network design, rainfall runoff modelling, groundwater quality evaluation and modelling. On experience in the application of remote sensing GIS and artificial neural network tools. Important research projects completed include east flowing river catchment water balances, establishing rainfall recharge coefficients in Mahandahi, Godavari, Krishna and Pennar deltas, and my apologies for my pronunciation, nitrate transport modelling in coastal aquifers due to faulty septic tanks, hydrological time series modelling, estimation of reservoir sedimentation rates using remote sensing, and stormwater management in Chennai and Hyderabad. He's worked as an adjunct faculty at San Diego State University in the USA under a UNDP project and was awarded a junior fellowship at IMI in Sri Lanka. He's published 125 technical papers in journals and conferences and 5 in-house projects completed on various facets of hydrogeology. So today he'll talk to us on behalf of his co-authors, N.C. Ghosh, Y. Siva Prasad and T. Vijay, and their topic is the potential of riverbank filtration for safe water supplies from saline coastal aquifers. So, Dr. Satyaji Rao, are you able to share your screen?
Yeah, good morning, all of you. Thank you, Chairman.
Thank you.
Yeah, could you able to see my screen?
Yeah, it's visible.
Yes, we can see your screen. That's excellent.
Thank you very much. Respected Chairman and Co-Chairman of the session and co-delegates, good morning all of you. First of all, I'm very much thankful to Dr. H.S. Sen, President ISCAR, for giving me an opportunity to share some of the research experiences at Deltaic Regional Center, especially on potential of riverbank filtration for safe water supplies from saline coastal aquifer I thank my co-authors for supporting me for this project. And this project is funded by Ministry of Water Resources, Government of India. With this background, our center is basically working on the east coast of India. This is the coastal region of India, including islands. But within the coastal area, we could able to differentiate between delta and non-deltaic areas. This is a very crucial aspect in a hydrological perspective. If you look at the east coast of India, you look at Mahanadi Delta here, the river formation, you can see geomorphological formation as a popular Mahanadi Delta here, and we have to look into this. This is the Godavari Delta and Krishna Delta. This particular region as a popular as KG Basin, Krishna Godavari Basin, and we have a Kaveri Delta, and these delta systems are predominant geomorphological features in the east coast of India. So when we started working on these coastal areas, we found a significant difference between deltaic formation and non-deltaic formation. So in that perspective, I could able to listed out some of the important aspects which are very, very important in a hydrological perspective, or in terms of it is in agriculture or drinking water or any purposes which are being very active in coastal areas. Especially we could able to see a lot of river meandering over a period of time. We can see through satellite imageries, and river branches getting a erosion during flood time. Lot of coconut gardens, we witnessed many coconut gardens which has fallen into the river. Those things are coming under river meandering and riverbank erosion. An important aspect which is a very burning issue in this area, especially sand mining. There should be a judicious use of the sand mining without disturbing much of hydrological activities or ecosystem of the riverine estuary system. And river mouth configuration is quite monsoon seasonal changes are significant. And also we have observed the backwater in creeks and river mouths or drains are increasing due to various reasons. Earlier, the backwater effect was limited to a couple of kilometers, and now we could able to see more intrusion is taking place through these hydrological pathways. And we also could able to see the contamination due to the anthropogenic zones, whether it's a canal water or drain water, and sea coast erosion also predominantly occurring in some of the coastal areas. And most important part which we never take into consideration sometimes, upstream activities. Lot many reservoirs are upcoming in these rivers, and lot of sedimentation is controlled by those reservoirs. In turn, the sea coast is having a threat hungry of the fresh sediment, which is very much required for marine ecosystem. So those things are so very, very important. Then especially wetlands and mangroves required more fresh water coming from catchment areas. Those things are altered due to the evapotranspiration, pumping pattern, and especially change in land use land cover. If you look at the especially changes in deltas and other coastal areas, lot of conversion of the land is taking place in terms of aquaculture. That is the predominant in Godavari Delta and Krishna Delta. Those things are also very, very important. As we are aware that natural disasters are also one of the important point. Last point is a high density of population. As fully aware that all coastal areas are highly dense population. And another important recent phenomena which could able to see because of the salinization, lot of RO plants are coming up in coastal areas, and indiscriminate use and disposal of the waste reject water from these things are very, very crucial. And if you look at this deltaic region and non-deltaic regions, we could able to integrate all the processes which are applicable to predominantly sometimes in deltaic region, sometimes non-deltaic regions. These are all the important processes which are happening in the coastal ecosystem of east coast of India especially. If you look at some of the statistics which are published in the journals, and we can see the impact of salt affected and salt affected areas, how these things are very, very important, because this is the stories which are available, success stories, so that it is proved that if we are not maintaining our ecosystem properly, or if we are not maintaining the salinity aspects in the coastal areas, these type of scenarios may come into other coastal areas also. This example is from the Indo-Gangetic plains. Similarly, land degradation, if you talk about, there are so many reasons, causes for land degradation. Among these things, salinity and alkalinity is one of the predominant activity over here. And this type of statistics gives an alarming alerts to the rest of the area that how to handle those type of situations. And these are all some of the published maps which are available in terms of electrical conductivity of groundwater, which was published by Central Groundwater Board. Look at this high salinity, more than 3000 microsiemens per centimeter, especially in Gujarat in area. If you look at the east coast of India, small patches which are slightly along the coast, we can able to see these high groundwater salinity zones. This particular slide I have picked up from the literature. It shows that if you look at the scenario of in India in 1951 to 2014, there are so many sources for irrigation. One is through tanks and other sources, canals and tube wells and other wells. The exponential growth, if you look at it, the 1970 to 2015, the groundwater irrigated area is increased by 3.85%. Whereas in 1950 to 1980, the canal irrigated is 1.98. That means it gives a situation that the dependency on groundwater is increasing in especially Indian scenario. Therefore, the assurance of the quality in terms of the high nutrients or sometimes the salinity intrusion to various regions should be controlled or monitored at least to avoid such type of worse situations. So dependence of the groundwater is very crucial in these areas along with the canal network system. So these are especially, this is the state of Andhra Pradesh after bifurcation recently. We have a lot, most of the coastal area is located in that, and electrical conductivity, if you look at this, especially in coastal areas, it is more than, sometimes you can see inland salinity also there more than 3000, and mostly the coastal salinity is 1500 to 3000 microsiemens per centimeter. These are all the state level scenarios are available with us. And also when we talk about groundwater, the soils also equally important, and especially look at the Andhra Pradesh, and we have the so many hectares here, 77,598 coastal saline soils, and if you look at the statistics, salt affected soils are around 10.3%. The statistics will help us to visualize the gravity of the problem. With this background, what exactly we are doing in our institute, I have listed out some of the explore and protect the freshwater resources in the coastal regions for whether it is a drinking or agriculture purposes, because still a lot of research needs are required, especially in coastal areas, in terms of identification of the freshwater potential which are existing in the coastal areas, whether it is a delta or non-deltaic areas. Especially if you are identifying properly the paleo channels, that will be very, very useful for leading to the fresh water which can be supplied to the various horticulture or drinking water purposes. So paleo channel identification, its protection is one of the topmost important in terms of freshwater potential which is naturally available in the coastal areas. Then another important which our institute is actively associated is identification of submarine groundwater discharge zones, so that if you come out with the zone estimation and quantity, then we can plan about it how best we can use these freshwater resources which is going to the sea coast. This is another important. Regeneration of water bodies, wetlands, many people are working on this particular area. And most important thing is groundwater recharge source identification. This is very, very important in the present circumstances, because we have seen a good number of wells which will fresh water, which may be connected to the upstream areas of the catchment, or it may be connected to the river course. These things are to be established using isotopes, stable isotope techniques and all. The groundwater recharge source identification is very, very important for sustainable development of the coastal regions. Then another important is conjunctive use. It is not a new, but still it is very useful, technique to take account of the available water. Then interlinking of rivers, and this government of India is promoting in a big way. Surplus rivers, flood water is diverting to the various other river basins to stabilize the agriculture activities or other activities also. This is the one of the important aspect. And water use efficiency. Now Government of India is promoting various technology for this particular aspect to save the water in agriculture sector. So among all these things, there is another technique which we are using. Of course, it is very popular, especially in Andhra Pradesh. This is called bank filtration or river bank filtration. Among all these techniques, our institute has associated in paleo channel identification and identification of groundwater, submarine groundwater zones, and interlinking of rivers. Now I would like to present a case study how the river bank filtration will help us to augment freshwater resources in a coastal environment. As you are fully aware that, especially when you pump the groundwater from the saline aquifers, most of the times the wells drilled by farmers, it will work for 1 or 2 months. Then they will come out with saying that our well was contaminated with the saline water. So these are all the things which frequently we observe in the coastal areas. So to overcome such type of situations, the pumping pattern optimization also very important. In that perspective, I wish to present one case study which we have designed and in the coastal areas of Visakhapatnam area. If you look at the Andhra Pradesh coast, especially, these are all the subwatershed delineations. The major this is a Godavari Basin, and this already said, this is a Godavari Delta, and this violet color is a Krishna Delta. Apart from that, lot many east flowing rivers are there. If you look at it here, Gostani, Sharada, Varaha, Tandava, Pampa. This is the hydrologically homogeneous region where it starts from east flowing Eastern Ghats and joins into the Bay of Bengal. So today I would like to present a case study of the Varaha River Basin, how it look like, what are all the problems here. This is the Andhra Pradesh located here, and this is the Visakhapatnam, and this is the Varaha River Basin. If you look at the DEM, it varies from 1,174 meters per the upstream of the Eastern Ghats, and it almost the Bay of Bengal. So this type of things are, this particular basin is having a problem with the salinity in the low-lying areas. So this is our issue now, how to address on that. If you see the synoptic view through the satellite image in pre-monsoon and post-monsoon, we can see the Eastern Ghats here and covered with the high density of vegetation here, forest and etc. This is not a perennial river. This is an ephemeral year. It flows around 45 days in a year, especially in the month of August, July and August. So with this background, this is the river mouth which I have taken into the case study. This is the Bay of Bengal, and this is an area we have a high salinity, but people are earlier this particular area people used to grow the betel leaves. That is one of the popular horticulture activity in this area. That indicates that once upon time this particular area is safe in terms of climate or fresh water, whatever you call it as. This is an indication. Now this crop is no more existing here. Most of these betel leaves have converted into various other cropping activities. This is one of the important make a note to observe in this particular area. And it is also highlighted in the print electronic media that these farmers are not getting the profitable, profitable income, and especially recent COVID. Also, they got severely affected because of the crop. There is no much, demand for this crop in this area. So with that background, we are working on development of riverbank filtration well in a coastal saline aquifer using geophysical survey, pumping test, regional groundwater flow modeling for sustainable use of safe water for domestic and agriculture purposes. So this is the entire, objectives which we want to attempt this particular task here. So this is the low-lying area of the basin, and some of the thematic layers we could able to generate to identify the favorable hydrogeological conditions to go for this type of riverbank filtration. The riverbank filtration is nothing but this is the river course, and we have a well near to the river bank. And if you put a well like this in a favorable hydrogeological conditions, you will get even though your groundwater is saline, the saline water is mixed with the river seepage water or and you will get the reasonable good quality of water. This is an hypothesis which we often explain through the riverbank filtration system, but this can be used for various purposes. But only thing, a condition is you should have a favorable hydrogeological conditions, and the subsurface should be connected to the your well as well as the riverbed. That is the precondition is required to go for this type of wells. Once you could able to establish connection between river water and groundwater, then we have to see if at all any saline water beneath the this groundwater, then how much time we have to pump to extract the safe water. That is a challenging task for in this particular technique. So we have used the electrical resistivity tomography surveys. Look at this now, a Google map where I have taken the snap of the river here. And these are all the profiles we have carried out to find out the hydrogeological conditions in and around the river. So we have taken one profile across the river and another two profiles, three profiles along the river. So after integrating all these profiles, we'll get a fair idea that whether it is really geological connection is existed between river and groundwater. So that we could able to establish over here. This we got some proposed RBFL location nearby this particular river reach. So these are all the profiles. And this is another profile, profile number 4. And we also conducted a vertical VES after identifying the tentative zone of the riverbank filtration to confirm the further vertical layers in this area. Then once we fixed the pumping test location, then we have drilled a well over there, and along with another piezometer to conduct the pumping test. And we have run this pumping for about 5 hours and see the stability of electrical conductivity after continuous pumping. This is what very, very important. Using the pumping test data, we could be able to estimate the transmissivity and storageability. So these things are very much required for regional groundwater flow modeling system. This is the flow domain, and using the aquifer characteristics and water levels, observed water levels, with this model domain, we could be able to simulate a regional groundwater flow model with the 2-layer system. The first layer is silty clay and the second layer is sandy aquifer. This is the river which is existing nearby. And these are all the aquifer parameters we could be able to get from the field as well as pumping test data. And this is the computed and observed steady state conditions, calibration of the model. Then we did some particle tracking approach to see which are all the wells which are influenced more by river water. That will give a very clear picture for us that among all the wells which are clearly affected by the river water. So this is the zone where we have focused much on that. Thereafter, we have used that which are all the wells coming more from this Varaha river to the wells. And we also analyzed the capture zone analysis using particle tracking technique. Look at this, especially in RBF well, recommended well, we have plenty of water which is coming from the riverbed. Okay, so with these things, we could be able to plot the combination of river water and groundwater mixing in the Varaha river basin. This is the RBF well where we got 74% which contains river water and 26% is coming from the groundwater. So these type of things which are then it gives a better water quality which is less than 1000 microsiemens per centimeter, better water which can be used for various purposes in that particular area. This particular combination of riverbank filtration 74% and 26% can be further confirmed by the isotope analysis also to see how much fresh water is coming to the groundwater. So this finally—
2 minutes, please, Dr. Rao.
Yes, yes, ma'am.
Thanks.
This is the final well which you could be able to recommend for particular village over here for various purposes. And this is the lithologs which we could be able to establish using the tomographical survey and vertical electrical survey, and do these two well profiles, lithologs and our tomography data which supports each other. Therefore, we have a confidence on that. Finally, we could be able to arrive this particular diagram, how the RBF well functions at particular this area where the bank filtration is taking place and geology supports, and how much water we should pump it, how many hours we have to pump it. These type of scenarios we could able to develop from these scenarios. Look at some of the hydro chemistry parameters which I have used for this is the river water, and this is the groundwater, and this is the mixed water here. Especially in terms of electrical conductivity, farmers are using the groundwater which is having a salinity of 2490. Now they are getting only 850 microsiemens per centimeter. So such type of advantages are there to use such type of wells, but we have to use very judiciously in terms of pumping. So therefore we also did some optimization of the pumping rates through regional groundwater flow modeling, and you can able to see scenario number 1. If somebody is pumping continuously from RBF well 8 hours, which government of Andhra Pradesh is giving a free power supply for farmers of 8 hours, because as a default they run the motor for 8 hours. Sometimes it is not advisable to run the 8 hours. So we could able to restrict them to the 5 hours only. Scenario number 1. And scenario number 2 is a continuous heavy pumping in 24 hours. What will happen? This scenario we could able to develop, and optimum pumping rates from RBF well without cone of depression effect. Maximum how much time we can take. Such type of things we could able to develop. And if you look at what is the drawdown pumping rates and water level depths over here, this is the optimum rate we have recommended, avoiding cone of depression in this particular area. These are all some of the field photographs while conducting the field work in this particular area. We were able to do it. So with these RBF well experiences, and especially working with the saline aquifers, and some of the conclusions we could able to arrive: significant decline of beetle leaf gardens in SR Ayavara Mandal due to soil and groundwater salinization. And geophysical tools are very useful to identify the RBF locations. And the optimum pumping rates are arrived using the regional groundwater flow modeling, and also optimization of the pumping period as well as pumping rate. The both are very, very important. Thank you very much.
Thanks very much, Dr. Rao. Again, we're running a little late, so I will ask you to hold your questions until the end of all 4 talks, and we can then take a bit of time for an in-depth question session. Sure. So it's now my pleasure to introduce our third speaker, Professor Elango. Professor was introduced in detail at the beginning of the session, but for those who have just joined us, he's from Department of Geology at Anna University in Chennai, and he's had a very distinguished career working in more than 25 countries and conducting major projects for international organizations.
Thank you very much.
He's the Vice President of the International Association of Hydrological Sciences from 2013 to 19, and is presently the President of the International Commission of Water Quality of IAHS. So over to you, Professor.
Thank you so much. Hope I'm audible and all can see my presentation. Yes. I'll be happy to share some of the work which we had carried out on this aspect, mainly on the issues related to sustainable management of coastal aquifers in the context of climate change. And we know in all over the world, groundwater is one of the major resources for agricultural activities. India, it is about 75% of our agricultural production depend on use of groundwater. And if you look at the coastal parts of India, coastal parts of India are intensively irrigated, especially as the previous speaker rightly said, the east coast of India, we have very large deltas, and the deltas are highly irrigated. And if you look at the southern part of India, if you take the southern part of India, we have only non-perennial rivers, and farmers exploit groundwater to the maximum extent possible, leading to groundwater depletion. In such scenario, we are also witnessing climate change, rise in atmospheric temperature by a few degrees every year. Then this results into changes in the groundwater. how one is rise in atmospheric temperature results into more evaporation, evapotranspiration, and during subsequent rainfall, the antecedent moisture content is very less. Hence, it takes more time for the rainfall to infiltrate into the ground. And thus, the recharge scenario gets changed. And rainfall itself, rainfall pattern itself is getting changed due to the climate change. In some places, rainfall is increasing. In some places, the rainfall is expected to decrease. And the intensity of rainfall is also expected to increase. In net, the number of rainy days are going to come down in many parts of India. Adding to this issue is the sea level rise. Hence, coastal aquifers are highly vulnerable, which are supplying groundwater for agricultural activities. Change in atmospheric temperature, many researchers have come out and said, and even during our lifetime, we have witnessed the rise in the atmospheric temperature. This is one of the work carried out by Fermi. And adding to this issue, right, globally, we are extracting large amount of groundwater. You can see in the top graphics, right, the towers, the black towers here, indicating the quantum of water, groundwater, which we are depleting, the scale on the left-hand side, right. You can see in most of the region along the just north of the equator, especially the countries in the Middle East and also America, China, we are extracting large amount of groundwater. So India is in fact number one in the use of groundwater. Adding to this, the climate change impacts, right? That means recharge is declining. So on one side, recharge is decreasing. On the other side, we are increasing the groundwater abstraction. So if you look at the coastal parts of India, this diagram shows what was the groundwater level sometime during the end of summer in the year 2007 on the left-hand side. Right on the right-hand side, you see a picture of groundwater level in the same month after 10 years. That means after during 2017. Though the picture is not very clear for those who are here, right? What I would like to highlight is, if you look at the eastern coastal part of India, groundwater has depleted by few meters compared to the situation that we were in a decade ago. Right? And what is the other issue, right? Adding to the groundwater decline in the coastal part, the sea level is also rising at a rate of about 2 millimeter to 3 millimeter per year in the east coast of. So when the sea level rises, and what is expected to happen is the seawater intrusion. Naturally, the seawater will get included into the land side, as you see in this picture. But when the level rises, the toe of the intrusion will also increase. That means we will lose part of our land to the sea and also part of our groundwater to the sea level rise. And in order to check what is happening in India, in the previous picture I showed you separately what was the situation in 2007 and 17. Here I'm giving you the difference in groundwater level between 2007 and 17. Right? So if you look at all the reddish, all the ones which are in this color, light green, yellow, orange and red, where groundwater table has gone down drastically compared to 2000. What does it indicate to us? That means in the last 10 years, groundwater level has gone down to a maximum of about 14 meters than what it was, where it was sometime during 2007. Right? But here there can be a lot of error, since we have just taken up the groundwater level of the month of May, 7 and 17. During that year, probably the rainfall would have also played a role. There are so many question mark in the results which I am presenting, but nevertheless, one thing is clear: certainly, groundwater level has gone down compared to 2007 in the year 2017. So, what does it indicate? So, they invite seawater to intrude into the aquifers. When this groundwater level goes below the sea level, obviously seawater will enter into the aquifers. In order to check that, we made a comparison of the region where groundwater table has gone below the sea level. Here on the top graphics, you can see the top two bars indicate, right, the groundwater table has gone down by -2 meters below ground level. That this was the situation in 2007, right? In 2007, around 1,500 square kilometer area of the coast, groundwater was below sea level, but in 2017, it has increased by about 400 square kilometers. I think the rest of the diagram is not necessary. So this is a clear indication that over about 10 years, we lost about 400 square kilometer of area where water table has gone below the sea level. Certainly, seawater would have included in these regions. In order to assess the situation in Chennai, we have taken up a major study, right? The Chennai city is located here in the east coast of India. This is the city part, right? On the left diagram, I'm using my cursor. This is the Chennai city, which is one of the largest city in, not the largest, fourth largest city in India, right? The groundwater supply is managed by tapping water from this small river basin located just north of the city of Chennai. About 5% of the city's water supply is met by tapping groundwater from this region. Right? The rest of the water supply is from the 4 major reservoirs. So if you look at the land use in this region, the land use here, just to show, since this conference is on agriculture, I would like to show the region just north of the city is completely intensively irrigated, right? All this yellow color are all agricultural area, and the green ones are forests, right? So you have so much of agricultural activity going on here. From here, actually, we are tapping little bit of groundwater to meet the city's water. The city is just located south of this area. You can see this picture, right? The picture on the right side is showing the 2 rivers, right? The 2 rivers are shown in this diagram. We have taken up a study to understand what will happen in future, right? In the context of climate change, variability in rainfall, sea level rise, what can be done? In order to do that, we had gone in for a integrated modeling approach, wherein we had fed in the climate data obtained from the regional climate models. Using that, we predicted the runoff, then what would be the impact on the surface water flow, and that we coupled with the groundwater flow to simulate the regional groundwater flow over the entire area, with the purpose of looking for some mitigation measures. Right? That is the objective of this model. For groundwater modeling part, we had used P-flow. This is how we discretized the region into several nodes, and we consider the diagram at the bottom shows the cross section here, having we assumed several layers to decipher to indicate the different geological formations that exist in this site. So this, after successfully calibrating the model, and these are all the results, right? You can see how our model predicted the groundwater level in this region. The region has got 2 aquifers, one aquifer at the top, which is unconfined, the other one at the bottom, which is lower aquifer. So here is the comparison between the simulated and the observed groundwater heads in this site. After having done that, we had also taken up only chloride ion for modeling. So though we called it a solute transport model, we consider chloride is a conservative ion that was derived only due to seawater inclusion. With this assumption, we had carried out solute transport model to understand the impact of seawater inclusion in this region. Right? Then this is the comparison of how we have validated the model. That is the observed and computed chloride concentration in the upper aquifer. This is for the lower aquifer. After having done this, now the model is ready. We had tried the various options that are available for us to mitigate the issue of seawater. So the various options which we thought of was several managed aquifer recharge structures. Can we middle with the pumping rate? That means, can you increase the pumping rate? What is going to happen? Or if you decrease the pumping rate, what may happen? Then we had also taken into account of the impact of climate change. How one is how the rainfall is going to change in the future, and how the climate change is resulting into rise in the sea level. So we had incorporated all these things in the model, and then we predicted. For example, the regional climate model predicts the rainfall is going to decrease in Chennai. This was taken as an input for the model which we have built for prediction. And with regard to managed aquifer recharge structures, the government has taken a lot of initiative to go for minor barriers along the two rivers here, right? We call them as check dams. Several check dams are planned. In total, 15 check dams have been planned in this site. Already 9 check dams have been constructed. The remaining 6 check dams the work is under progress, which are shown here, right? That means all the brown ones are existing check dams, the green ones are under construction. Then we had also thought of the old check dams. If you increase the height by 1 meter, rejuvenate all the existing water bodies. All this, we have several water bodies, but most of them have not been maintained properly. Suppose if you rejuvenate them and link these two rivers along here, right? Then what will happen, right? Then there is a canal running more or less parallel to the sea, which is known as Buckingham Canal, constructed for navigation long time ago. Suppose if you rejuvenate and fill it with excess flood water. Like that, we thought of several measures. We have incorporated all of them in the model, and then we predicted the groundwater head at the entire model area. So this is one of the results showing the impact of sea level rise on the groundwater level. As the sea level rises, groundwater level is also expected to rise. That is what is indicated here. Then what is the impact of all these measures on the seawater intrusion? I told you several measures. One of them is the RS is the recharge structures. All the recharge structures are put in place, and we are increasing groundwater pumping by 10%. Suppose if you decrease groundwater pumping by 10%, what will be the situation? So here is the concentration of chloride at different times. So what happens due to all the measures which we are considering? So as expected, if you put in all the measures and reduce pumping, chloride concentration will decrease from the present level, as you can see in this diagram. And here, this is how we have also simulated the seawater freshwater interface with the help of this model. Since the model is run on a daily time step, we continued this prediction for further period of until I think this work was done 4 or 5 years ago. We predicted the groundwater head until 2030. Suppose if you continue with the present scenario, that is business as usual, this will be the situation in 2030. That means what you see here is these are the 2 aquifers in upper aquifer. This is the groundwater table, more or less at the sea level. So seawater will improve. Look at the piezometric surface of the lower aquifer, which is very much below the sea level. So large seawater intrusion will take place up to 20 kilometers inland by the end of 2030. Suppose if you increase pumping, the situation will become much worse. Right? So if you go in for mitigation measures, which I told you on the previous slide, the situation may not be very alarming as you see in this picture. Then the same is shown in the plan, right? The situation in 69 was like this. In 90, the situation was like this. 2000, 2004. In 2004, the entire region got salinized. Pumping from this location was stopped. That means pumping to meet city water supply was stopped. So the situation got slightly improved. This was the situation in 2015. If you put in all the measures which we had proposed, the things will improve to this level. That means we'll gain at least 5 kilometer area will be recovered in the next 10 years. So this is how managed aquifer recharge is the way forward to mitigate the problem of climate change. And as I told you, certainly climate change is going to affect the groundwater resources. Nothing we can do rather than adapt ourselves is the only way. And we can also adapt ourselves by increasing the surface water storage, thereby promoting large amount of groundwater recharge. But though we had suggested that the check dams, maintenance of these check dams is very crucial because of clogging effect. So every year we need to clean them. So with this, our work also got attention in the media. With this, I thank you all for attending this session. Thank you very much.
Thanks very much, Professor Alango, and thanks for keeping so well to time. I think because we had lost a little bit of time, I will continue with the next speaker, and then we can have a leisurely question time after the fourth speaker has spoken. We are in the fortunate position of not being pressed at the end of the session. So our next speaker will be Dr. Ranveer Singh. He's an environmental hydrologist with specific research and teaching experience in catchment hydrology, irrigation and agricultural drainage systems, and specifically with water productivity and water footprinting science in agricultural landscapes. He holds a Master's in Soil and Water Conservation Engineering from CCS Haryana Agricultural University and a PhD in Environmental Science from Buckingham in the Netherlands. He did a postdoc at Iowa State University in the USA and a research fellowship at Western Sydney University in Australia. He's currently working as an associate professor in environmental hydrology and soil science at Massey University, New Zealand, and is affiliated as a visiting professor at the Faculty of Agronomic Sciences in the University of Chile, Santiago in Chile. He's been a member of the Water Footprint Network and has participated and contributed to FAO's work on the LEAP guidelines for water use assessment of livestock production systems. He's published over 75 research articles and serves as associate editor for Agricultural Water Management Journal. So over to you. Thanks, Dr. Ranveer Singh.
Thank you, Robin and Professor Alango. Very interesting talks. Thank you to Professor Rao, Professor Ashish, and Alango gave a very detailed talks, very kind of specific and interesting. My talk is going to be a bit more high-level talk. When Professor Sen asked me by email that would I be interested in giving a talk to seminar that we are organizing on transforming the coastal zone for sustainable food and income security. So I thought about it, I thought about the theme, and I said, well, yes, I will do a talk, and I will focus on my talk on a broad level, a kind of a reflecting in that talk onto the challenges we have into our Indian context landscape, and how we can do some practices or some assessments that can help to improve the land and water productivity and protect the water quality into Indian landscape in coastal ecosystems, and bring some experience of work that we are doing here in New Zealand around our catchments that are in the coastal environments, some of the challenges we are facing in those landscapes, and what we are doing to address those challenges. So my talk is a bit of high-level talk, so it will be more a bit of a conceptual ideas that I would like to talk that could be helpful, could be considered, could be think about, that how we can improve the land productivity, water productivity, and income, and also the sustainability of that into these systems. Now, in India, we have seen a big effort in 70s and 80s to increase the food production for the food security, particularly around what we know green revolution. And this is one photo of that result of that green revolution that we had now lush green fields full with the grains like wheat and rice. It's me working in my college days in Haryana when I was a student there. And my background is from farming. I come from a farming family in Haryana state. So I know that part of agriculture landscape and the challenges that we face and those things pretty well. So we had this drive into our system in name of Green Revolution that led us to produce a lot of grain that help us to attain the food security as a country, to the level that now we are even exporting those grains to the world market. We are, as a country, exporting increasing amount of wheat and rice to the international market, obviously meeting the domestic needs as well. Now, if you look at a lot of this transformation was possible into our landscape was for a couple of reasons, couple of inputs that we had into our system or we have in our system. For example, high yield varieties, crop varieties that were brought into the system and trialed, increased input of fertilizer into the fields, and also very importantly, the increased amount of water input into these fields, irrigation, the development of irrigation network, and more importantly, also the development of groundwater irrigation, that wonderful technology we start using at that time, that allowed us to produce more and more grain into our landscape, which did its purpose that we achieve the food self-sufficiency, and we are importing those things. Now, if I take this back to the theme of the seminar, that we are looking here how to increase the productivity and income security, food and income security going forward into the future. So in that income security context, I want to look at that. What are the gains of this grain production we have in northern India or India as a whole? So I asked one of my colleagues here to do a quick back of envelope kind of calculation that what is the return we are getting by producing this wheat and rice and exporting this to overseas market. And he did some calculations which are shown here. For example, that the gross export value of wheat will be about 20 rupees per kilogram. For rice will be about 40. It's less for non-basmati rice and more so for basmati rice. And if we account in this export value, the amount of subsidy that we put into in terms of energy or fertilizer, and then you discount that cost or account that subsidy, the net export value of wheat goes negative, and for rice it's quite low, and for non-basmati rice is particularly quite low. So the point I want to make here is that growing more grains is not going to really probably help the income security of our systems, of our farmers into that landscape. We had to start thinking about something else into the system. And moreover, the producing these grains into system, and as the previous speakers were also talking, is having a huge effect on our groundwater systems into inland basins like Punjab, Haryana, but also in the coastal environments like Professor Alanga will talk about the effect into the coastal areas on groundwater, and those are affecting in a way that our groundwater resources are unsustainably pumped. They are decreasing into the level, and they are not sustainable going forward. Now, I had another quick look at and put like how much this wheat and rice export out of India equates to a groundwater level decline into our system. So I did a very quick calculation a few years back, again, very back of envelope calculation, no detailed modeling here. I got some number about like how much rice and wheat is being exported on average out of India. I made a simple assumption there that 50% of that rice or 75% of wheat that is procured comes from Punjab and Haryana state, and then amount of water that's used to make and rise, I equate that back to how much groundwater table will be declining over Haryana and Punjab if I count that water exported in terms of virtual water exported in terms of those grains. And you could see that it equates to about 50 to 60 centimeter per year water table being depleted associated with this grain export. So basically, we are producing this system, exporting these grains, declining our water table, and the net gain of that is not much to increase the income security of our farmers. So we have to start thinking about a more productive system, more high-value, nutritious, water-sensitive productive system into our landscape which are suitable there, instead of producing more grain or thinking about more grain production and how do that make work. What horticulture crops we can grow, what fruit crops we can grow, how we can grow more dairy, for example, and what are those suitable crops into our landscape, and what are the productivity values, what's the return of those crop systems are in terms of crop water productivity, in terms of a dollar value or rupees value, how much water we are extracting by using per meter cube of water use, how much nutrition we are generating by using per meter cube of water use. So what I'm proposing here is that we should start looking on our systems like that by using this concept or model of water productivity and assess those into the water productivity values. If we look on the current value of water productivity of major crops of Indian system, a recent report by Bharat Sharma and colleagues looks at that, and you can see that the water productivity value and economic water productivity value of major crops we have in India is quite low compared to many other crops I can talk about, like high value crops that we could grow into those systems. So there need to be a shift, thinking about how do we shift those crops into return more nutrition, more value in terms of rupees or dollar, or more crop per drop. And the other aspect that comes to this growing this productivity in the system is that we have to be careful about protecting the water quality. And this photo here I like to show again and again in my talks, is a very good example that this boy is standing in the middle of the water and trying to get some water for drinking. If the quality of the water is degraded, that's a big challenge and it's not of use. So we have to protect our environment, and within that environment, we have to grow the productivity of our landscape. And one of the challenges into the environment in agricultural systems is what I call is this nutrient challenge. In one hand, we are facing with the limited nutrient supply, for example, phosphorus. Nitrogen is not that limited, but it requires fossil fuels and all those associated impacts of that. But these nutrients, if we are not managing them properly and applying them properly, they leak with our groundwater system, with our runoff, and they goes to this sensitive environment of freshwater bodies in coastal lakes, into coastal estuaries, and then they create this algae growth, the nuisance of all this pollution that comes with it. And that is a huge challenge in many, many places around coastal environment, and we are faced with some challenge like this into our New Zealand environment. How we can address that? In New Zealand, we are taking an approach about developing a framework, what we call the land use suitability. So what we are looking at is the land parcels, that what is the land productivity we can get, what alternate land use can be done on those land parcels. So that's our productive potential. And then from those land, depending on the soil type, geology, groundwater system, how much contaminant could be transferred or flow through and can go to those receiving environments. That's the relative contribution. And then how much is the pressure into the system? Because all this environment, they have some assimilative capacity, some have less, some have more. What's the pressure on those systems is, and then we quantify some indicators of pressure. So, and then you combine your productive potential, relative contribution of different land parcels to contaminant risk, you can call it, and then what's the pressure into the system is, and then you can combine them and create some map of land use stability, where we should do what within the safe limits of environment, and how we can kind of use this information then to start informing our metrics of decision making that we should be doing the right thing at the right place in a way that we have productivity gain within the environment limit. And that's quite interestingly, when you look detail into the landscape, for example, we are doing some observations and looking on the nitrate into different landscapes, like how the nitrate, one of the contaminants that's quite important for fresh water, for drinking water quality, that how that nitrate flows from different lands to the water. And we could see clearly that if we go into different places, we can find in some landscapes under the soils that there is hardly any nitrate, and other places there is nitrate into that. So what is that telling us? That this environment of soil, the hydrogeology has a big influence on how that nitrate is being leached from those places and transferred to the receiving environment, hence the relevance to the land use suitability thing. So we look at that, what's the process of that nitrate attenuation is into these landscapes. So we find that in some places, if there are suitable conditions, there is natural capacity of assimilating the nitrate by the process of denitrification into groundwater, means that those lands are much more resilient in terms of doing the land use activity on them as compared to some other lands where they are much more leaky and they are directly connected to our freshwater environments. So these are more risky lands. And we are using this kind of understanding of our landscape, our geology, our soils, our climatic environment in those to develop some kind of this classification of our landscape where we can say that these lands are more resilient. They have high capacity to deal with the agriculture, for example, green areas. And these red areas with the low capacity along the river corridors, they are probably much more vulnerable to cause the pollution to our waterways. So we have to manage those carefully. And that kind of thinking about mapping our land's capabilities and suitability and informing that to make our right choices of crops, where we should do what, is kind of a conceptual model of land use suitability we are developing to inform the planning and management of our areas, so we have more productivity and less environmental impact into the system. Now, in coastal environment, you probably have seen, at least in New Zealand, a coastal environment, like we see that quite a bit of part of lands, because of the shallow groundwater level, they need drainage systems. And if we install those drainage systems and let them keep on running freely all the time, they become a very critical pathway to take the nutrients, like nitrogen and phosphorus, out of the farms to the receiving environment. And what we are trialing on them is that how we can manage those controlled drainage systems in much more flexible way, that we can drain the land when we need to drain it, to dry it, to cultivate, and to put the crops into it, and then hold the water back when we don't need to drain it, even to benefit the crop, and by making this kind of controlled drainage structures into all those drains, that if we pull this pipe down, then it will start draining, and if we raise it, it will hold the water back. And that has huge effect on how much water is draining out of this drains, for example, before control and after control, you can see. And then we also see the reduction in the concentration of nitrate if we go from control to uncontrolled, like 10 ppm in uncontrolled and about 1.4 ppm in a controlled environment. So benefits for reduction of nutrients and the flow out of the land, keep those nutrients, the value of those back into the field by managing the drainage into the system that way. Other practice we are trying is creating these wood chip bioreactors. These are basically the tanks that they open into the field by a drain, and they are filled with these wood chips like pine tree chips. And basically what we are doing is here, by creating these wood chips and filling them with water that's come from the drain with the high nitrate, we are creating a reducing environment for the nitrate to get denitrified. So on the other end of this bioreactor, the water will come with very low nitrate. For example, here, this is high level of nitrate coming into the bioreactor, and on the other end, we get very low level of nitrate going out of these bioreactors. Here I swapped the sensors so you can see. So it's kind of a treating system that we can build to build the attenuation capacity into these landscapes and can denitrify our nitrate load going from these landscapes, kind of ecological engineering into the land. And there are a number of practices we could be thinking about: how to control drainage, how to manage it, how to harvest the water that comes with the nutrient out of this field, put it back into irrigation system to recycle, how to link our drainage systems with the natural wetland or created wetlands to manage these drainage pathways of nutrients into this environment, so less nutrients are going to the coastal ecosystems or receiving freshwater environment, so the water quality is protected. So I hope with this one that there are some of these science-based models, conceptual models that I'm talking here, like use of water productivity as a model, use of land use suitability as a conceptual model, edge of field practices like managing the drainage, control drainage, bioreactors. They are going to be helpful to achieve that food and income security and sustainability of that into those agriculture environments to help us identify the high value, nutritious, water sensitive crops. That's what we need to focus on. We want to generate more crop per drop, more value from out of those crops, and more importantly, more nutritional value from those crops. And that's the model we need to test. What are those crops? That's the big question. And once we identify them, we can then think about how do we plan and incentivize that we can put those right crops in the right part of our catchments, right part of our landscapes, in a way that that load, that contaminant load that comes out of that agricultural activity is then either handled naturally by the landscape or minimized by other practices. So matching the land use productivity with the land suitability is quite important concept that we need to do that. And also then build some of these practices on the edge of these fields by making this, building this attenuation more resilience into our system. And these are some of the practices we are trying here in New Zealand, and I hope they are useful in other environments too, that can help to achieve that food, increase food production or land productivity with minimum environmental impact. With that, I stop here. Thank you.
Thanks very much. Again, another fascinating talk. What I've found really interesting in this group of talks is three main themes. The first is how quickly things are changing, either as a result of climate change. Professor Ashish showed us the very dynamic situation in the deltas, or as a result of human use with the groundwater pumping. The second theme that came out for me was about the importance of water quality, that often there's just a focus on water quantity. And I think, you know, three of the talks all really focused on the importance of looking at water quality, whether it's salinity or nitrogen. But I was also very heartened to see that there were solutions put forward. So what I'd like to do now is throw the session open for questions. I guess probably the easiest way to do it is if you just want to unmute yourself and put up your hand, please feel free to put questions to any of the speakers. Does anyone, I always have a lot of questions, so I have questions eventually. But would anyone else like to start?
Can I?
Yes.
Yeah.
Certainly.
So I have one queries for Professor Ashish Kumar. Sir, regarding freshwater reverse discharge, is there any gauging station in Hugli River, or in that case also they that total runoff from the catchment they used to consider during measuring that total river freshwater river discharge? Sir, unmute yourself. Please unmute yourself.
I have unmute. No?
Sir, it is again muted.
Hello.
Hello, now it's audible.
Yeah. Yes, the runoff modeling is actually done. But actually, if you just consider the total Indo-Gangetic basin, the total flow is estimated in the upper parts. That means from different channels, the flows are coming into the Indo-Gangetic plain from different sides. But ultimately, when we are considering the flow at Navadvip, the Navadvip gauging station is there, and then in Farakka, but it is gradually reducing to the south of Hugli river systems, because it is estimated that only 10% of the fresh water is coming, if you just consider or compare with the total flow of the fresh water into the Indo-Gangetic plain to the Sundarban area. So the ecosystem services of the mangroves are actually suffering because of the shortages of the freshwater inputs into the coastal zones. And that's why the mangrove degradations by this process, it is going on the sea face also, in the inner parts of the Sundarbans and also on the sea face.
So it's a mainly model output and estimation, not that direct any gauging.
Yeah, it's the estimation. It is estimations. Okay. And from the remote sensing modeling also, we can do it.
So I have another one clarification from Dr. Satyajit. Sir, hello, sir.
Yes, go ahead.
Sir, regarding riverbank filtration techniques, so is there any modification of the wells itself, or it's just a pumping that controlling the pumping? It would be the riverbank filtration techniques would be applicable.
Actually, if your depth of the well is more and you want to stop the top layer, leaking of top layer groundwater into down, that you have to take care. Otherwise, what happens, instead of getting a mixed water, you will get the top water which will be leaked into the bottom. So those type of precautionary measures you have to take.
Okay. So in the pipe itself, that there should not be that techniques actually.
Yes, sliding from top aquifer water. Yeah.
Dr. Rao, while we have you there, I was really interested to see that the proportion of river water was so high. Had you expected that river water would displace groundwater to such an extent?
Actually, the well which I have selected is very close to the river bank. It is almost, you can say, from the river bank 10 meters only. I have chosen such a well because of the salinity problem. So that's why the contribution of river water is more. It is just 10 meters from the bank.
Okay. Professor Alengo, as co-chair, is there anything you would like to
No, nothing. No, I don't have anything. Thank you so much.
Well, if you'll allow me, I have a question for both you and Dr. Singh, that you both put forward solutions for the different problems you were addressing, which function at a landscape scale, at a bigger scale. So for the managed aquifer recharge, you obviously need activity over quite a large area. And Dr. Singh, you were talking about the importance of matching land use to land suitability, which again has to be done at a landscape scale. So it sort of raises the problem of how we manage to coordinate different groups to act together. Do either of you have any insights into that? For example, Professor Alengo, how has the managed aquifer recharge work worked in the area that you've been looking at?
Is the question to me or?
Yeah.
Yeah. The question is how I have.
Do local governments get engaged in?
Of course, yes. As I had told you, certainly the check dams are being constructed with the funding by the local government, state government, right? 15 check dams are under construction. Right? Certainly, the government is so keen because the people over there are affected due to seawater intrusion. Not only that, even the government is not able to tap groundwater to meet a little bit of cities requirement.
Okay. Dr. Do you have any thoughts about coordinating approaches?
Yeah, thanks, Robin. It was a very, very challenging and interesting question. I suppose that how that could happen there are two ways and a combination of those. For example, what I believe, for example, is one is to take this information about what is the impact of you do this agriculture on your resources and how sustainable is that, to share with the farmers and residents of those areas, to show them what's the ultimate goal would be, or outcome would be, and trying to educate and convince them that this is the right way to do the things in that way, because that's more ensuring the long-term sustainability of your farms, your children and their future and going forward. I think that will appeal a lot once people start understanding their systems and getting idea that how they are being impacted. Government also has a role. For example, in New Zealand environment, we are working on both sides, like obviously working with farmers and education on that, but also there is a environmental regulation that comes into our systems. So our government now asked our regional councils who are responsible to manage the water quality in our regions to define that what should be the water quality standards in our catchments, and they should be very high. And how do we meet those standards in terms of different contaminants that comes from these farming lands? And now the idea is going forward is that the farms into landscapes, they will have to have some kind of a whole farm planning and estimate what their likely risks are in terms of losses to the environment, and how do they are going to manage that. And they had to work that within their limits that are being kind of discussed on those farms. So bit of regulation, bit of education, and offering the solutions to the communities is kind of working bottom-up, top-down approach together to drive the change towards more environmental sustainability and getting the productivity within the system. I think that one of the big challenge for us is in many of these places has been is that we focused on productivity so much, and rightly so for the region, but we forgot the side of the environment for some time. And I think we need to bring the productivity and environment together to look on how we can gain the productivity within the limits of environment we are working with, rather than going against the environment of that place. Otherwise, we will be in problem in one or other way in some time.
Thanks very much. Now, I see we're very privileged to have Dr. Sen with us. Would you like to make a comment?
Just a minute, sir. One raised hand is there. Dr. Robbins, please.
This for me.
No, earlier that our Sujit Desai raised hand.
Yes, sir. Yes, sir. Yes, sir. Thank you very much, sir. With the permission of respected chairman, I would like to ask two questions. One is to Professor Paul. Sir, actually, I would like to just know what was the extent of influence of this tidal in the estuary, sir? Because here in the west coast, like I am working in Goa, even we have the estuarine system. So here almost half of the length of the river is affected by the tidal waves. So almost 50% of the river is estuarine, comes under estuarine ecosystem. So what is the case in the east coast? I would like to answer.
Yeah, thank you. Very good question. Actually, in our West Bengal, I have seen that 300 kilometers ingression of that tidal waters through the estuary actually take place. Okay. In the dry season, particularly but in the monsoon phases, because of the pressure of the fresh waters from the landward sides, it pushed seaward. But for the cases of Odisha, I have seen in Subarnarekha estuary and also in Chilika lagoon, I have seen that in the dry season, there is also the similar thing happening, but it is about 70 kilometers or 80 kilometers upstream, the tide waters actually penetrating. And that's why the tidal sands are actually pushed inland through the estuaries. And that's why in our Kolkata, where Hugli estuary is located, there the siltation is taking place at present, and the river Hugli is filled up with the sands, and that are actually deposited by the tidal sands. Understand?
So due to that reason, sir, there are more sandbar formation?
Yeah, exactly.
Okay. Sir, thank you so much, sir.
Yeah.
Sir, I have one more question to Dr. Rao, actually. Sir, I just wanted to know how the sedimentation in the rivers and the coastal erosion, how we can link both of them. Like we know that in the coastal ecosystem, due to presence of dams and reservoirs, the sedimentation level is decreasing, as it was mentioned by you. So how we can interconnect that sedimentation in the rivers and coastal erosion? How we can interlink that, sir? Sir, please, if you can unmute, sir.
Oh, sorry. Yeah, it's fine. You see, if you look at the coastal areas, first of all, somebody is interlinking between the sediment which is coming from the rivers and versus the erosion which is taking place through sea coast. Okay, and these two are not directly correlated, but definitely they are interlinked. Okay, there are so many coastal activities like ports, etc., upbreak structures, and so many things which are causing sea erosion, right? When you talk about river sedimentation, if it is drastically reduced, because you have to come out with the quantitative analysis, how much supposed to come to the sea because of the reservoirs, how much it is reduced. Because river sedimentation is mostly directly influenced mostly on marine ecosystem, right? Then later part will come to the sea erosion. Quantitative sums at this contest, I cannot come out with because of this particular area got affected because of the sediment reduction of sediment from rivers. Definitely, there is a case which is available in our Andhra Pradesh is Upada coast, where it is directly we can see last 15 years, 500 meter is got inside the sea because of the seashore activities, and we also calling as a reduction in the sediment. So these things have to be worked out in a quantitative terms rather than saying a qualitative statements. Thank you.
Yes, sir. Actually, one thing we know that, sir, like in West Coast and East Coast, there is a lot of difference, sir. Because in West Coast, there is coastal erosion, whereas in the East Coast, coastal accretion is happening. So there is deposition of the soil instead of erosion.
Yeah, some areas.
That is the case, sir. And one last question, sir. Like you mentioned about this one, sir, riverbank filtration. Whether it is similar to the freshwater skimming wells or it is different from that. Even the concept of freshwater skimming wells, almost it is similar to that one.
Yes,
Sir.
Skimming
Sorry,
wells.
can I just interrupt a minute to say goodbye and thank you to Professor Alango, but we've just lost him, so it's okay. Back to the questions.
Yeah, couple of questions. One to Professor Paul, and then to...
Sorry, Dr. Sen, can we just finish this question first, and then we'll open the floor for you. I apologize.
Skimming well is something related to the upcoming phenomena, I call it. Okay,
yes,
floating water.
Yes,
here is slightly different from that. Okay, I hope you got the point. Yeah.
Yes, sir. Thank you.
Okay, now, Dr. Sen, please, can we open the floor?
Yeah, I have put two simple questions to Professor Paul. First one, I just wanted to, because I have put a hypothesis which I'm nursing for quite some time, and this I have made some publications, and possibly it has got the attention of the government also, that Indo-Gangetic alluvium plain, the Ganga River, which is running for 2,000 kilometer stretch, right from Uttarakhand to Farakka barrage. There is a deteriorating hydrological behavior of the water. As a result, the salinity in the Bangladesh as well as in India is on the rise. Nobody has projected from India in that context, but from Bangladesh they have been possibly propagating this issue for quite some time, and the onus possibly lies with India because they have this 2,000 kilometer long stretch is within India. So this because of various factors by the people who are encroaching upon the water, diverting water in between, and then there are various other issues. The hydroelectric stations in Uttarakhand, a number of them are there. They are also drawing water. So I think government has become a little strict about it now. So I think this, whether you agree with me or not, this is what I want to know. Number two, Number two, and then what to do about it. Number two is Professor Ilango. I just wanted to know, Professor Ilango, you have given a very frightening picture that groundwater level is being receded by as high as 14 meters in some cases. Then you confine your attention to Chennai and other places where you are mainly basing your work. But this is really frightening. And then you have any solution to this, and whether you have extended your work other areas as well to confirm this. These are the two questions. Yeah.
Yes, you are absolutely correct, because I am agreed with you, because the freshwater diversion, actually it is taking place along the Ganga course in Uttar Pradesh and Bihar, in another states also, Uttarakhand area. So that's why actually the lower courses of the Ganga are actually suffering from the freshwater inputs. At the same time, I want to make another additions, that the tributary systems of the Hugli and Bhagirathi, that is in West Bengal, the streams like Damodar, Moirakshi, Ajoy, and also Kangshabati, these rivers also contributed the huge amount of the fresh waters into the Hugli and Bhagirathi systems in the past. But presently, we have seen through the PhD research by my scholars that the reduction of the fresh water is also, from this part, is also responsible for the reduction of the fresh water into the Hugli and Bhagirathi systems. And that's why the tide water pushing to 300 kilometers up to Navadvip. And the soil salinity also at the same time, side by side, it is increasing towards North Chobbish Pargona, and also on the bank of the river Hugli and Bhagirathi. That is observed just nearby Barakpur, and towards north of Barakpur sides also, the soil salinity is very high, particularly during the lean season. That means in the dry seasons, when the freshwater shortage is actually taking place in the lower course of the Ganga. So this is a real problem of this area.
Another factor that plays a very significant role is the retreat of the glaciers up in the Himalayas also. That causes reduced flow of water through the Ganges.
Yeah. But actually diversion is also very significant in this for agricultural irrigation practices.
Thank you very much. Dr. Ilango is here.
No, Dr. Sen, Dr. Ilango had to leave. He messaged that had to be in another session. Okay. So I'm sorry, but we can't answer his question. Does anyone have any more questions or comments to make? It's been a most interesting session.
On the whole, all the presentations were excellent, and then it was very absorbing under your vibrant leadership as the chairman, and Professor Ilango also co-chairing it. Thank you very much. Dr. Ranveer Singh, I was not able to be present throughout your presentation. I am shuffling between the sessions.
I can.
We're very honored to have you join us at all.
Thank you very much. Thank you very much.
Thank you for the opportunity.
Thank you.
I would just like to add my thoughts to that as well, that they were really very interesting presentations. Professor Ashish, I was sure you couldn't get through 59 slides in 20 minutes, but you did. Yeah. And go back and look at them more slowly. So thank you all very much for your presentations and for your very thoughtful discussions. And I think really now we can wrap it up. We were in the fortunate situation that we didn't have a full session, so we've had time for a really good discussion. So thanks very much.
Thank you.
Thank you. Thank you for the opportunity.
And thank you for the tech support.
Yeah.
So
yeah. Definitely.
Just a minute, sir. Now it's the time to vote of thanks to our chairman, co-chairman, and as well as the invited speaker. So on behalf of organizer and on behalf of ISCAR, I would like to thank Dr. Robin Johnstone for chairing this session. Also, I would like to thank Dr. L. Ilango to co-chair this session. There are 4 invited speakers: Professor Ashish Paul, Dr. Y.R. Satyajit Rao, Dr. L. Ilango, Dr. Ranveer Singh. On behalf of organizer, I would like to thank all for their invited talks. Also, I would like to thank Dr. Satyajit Desai for recording this session. So thank you all.
Thank you very much.
Thank you,
Yeah.
sir.
Thanks, everybody.
Thank you.
Bye.
Thank you.
Goodbye.
Goodbye.
Bye.
Work out how to get out.
Yes.
Hang on, I'll just unmute. Thanks so much for your help with all
Thank you.
the technology. It was very reassuring to have you there.
Okay. Thank you.